So yes, everyone, tonight we are back. We're back tonight, everyone, and we are going to continue um, with our project here. So, where was my diagram? I don't know where the diagram went. But anyways, yeah, so we want to, I think what we're going to aim to do soon is to finish filling out the metadata, and then we're going to throw that into a BigQuery table, and then at least all the metadata will be in the BigQuery table. So to do that, we still have to add a couple things to the metadata. Most of the items have actually now been added to. Oh, I need to find that file. I'll just get off of Confluence again. For right now, most of the things have been added to the metadata. So remember we had this, the metadata I think is, open existing diagram. Oh, it was actually there. Wait, no, that's the older version actually. Open device. Okay, yeah, I think this was the total one. But anyway, so basically the river metadata, and we might actually want, we're going to throw the river metadata into BigQuery once we have it completed, because then that will be a useful table for people to query. So before we're actually talking about adding some of the fields, and creating kind of a Terraform schema, but that will probably be more useful once we have the actual idea. River infra. Okay, yeah. Yeah, once we have more of an idea of what it should look like. Because right now we just kind of have this, and we need to kind of, but as we add things here, we'll also add things to this schema. So first we're actually going to, on that note, basically go to the metadata and then see what fields are currently in it and kind of add them to there. Also, a good thing to do is to probably to look at so basically, yeah, we have an ID, we have latitude, longitude, we have the name, we have the time zone info. I don't know that the time zone info is actually going to be that useful, so I don't know if it's actually needed when we create the table. I mean, we might take just this part of it and write it as like original elevation or something. But yeah, so we have ID, state, latitude. We don't want to latitude. Oh, I think this should be longitude. Yeah, that makes sense. Wow, finally, Copilot did something useful. Gauge height. So this is what Copilot is suggesting. And yeah, I mean, if you look at this, uh, yeah, some of this is, it looks like, some of the problem I've had with Copilot is it's basically suggested things that are plausible but actually aren't correct, which I've seen it do before. Like some of these are actually, well, actually, yeah. I mean, this looks plausible, but it's actually none of it is the specific thing we need, except maybe time zone. And so, that's not really correct. So I'm not going to do that. Okay, so this should just be latitude. And then this should be longitude. We can move that there. And then some of the things that we'll fill out. It's like, okay, we have elevation. I don't know why elevation is a list. I wouldn't think that should be that. Soil data we're going to keep as a JSON data structure, I think. And then what we can do, so some of the stuff we're going to do is we're probably going to add other weather stations that aren't just dependent on ASOS. But we're going to keep the ASOS. So what we're going to do is create a new field called closest ASOS station, I think. Name. Oh yeah, I'll just copy this. See, this would be actually a good place for it to autofill. Because, like, that. But, of course, it doesn't there. So this is going to be the ID of the closest. And this should be an integer, I think. Mode, nullable. Or wait, no. Actually, that should not be an integer. It should be a string. So that will be the closest ID. And we will let people have the station data, but it will be nested JSON, I think. So, but in any case. So we'll re-add this. So we'll have this as another item. And this could be, yeah, that should be a float 64. And particularly this metadata, I think when we add everything is going to be a fairly wide table. Now I'm going to look at actually querying some of the nested JSON. Yeah, I mean, I'm still wondering how good this is. So obviously stations will probably contain still this ASOS sub data here. I don't know why elevation is nested. Okay, so when we put this into our schema, it won't be some nested shit like this. It will just be elevation, I think. So So the elevation should, I think, be a float. Okay, so that should be a float. And there are actually some other parameters we should have too. We should be returning if a thing has essentially the yeah, let's throw this in as elevation. We're gonna call this elevation. And then, oh yeah, I won't put that between those two because then that will be confusing. Actually, that should probably be there. No, that's not what I want. And then name. So this is going to be JSON. I think that's how you would do that. I think that's right. I don't know if that's actually right, but we'll leave it like that for now. And anyway, so that's kind of capturing some of that. We'll also have the soil data. I'm gonna double check that that's right. I want to look at the type. Let me see. BigQuery column types. Mode. So actually for some of these I definitely want nullable. I want nullable set to false actually for some of these. Nullable. So I think I can just delete that maybe. Or does it require a mode? Let me see. I don't really get the nullables thing for mode anyways. But clearly ID can't be nullable. And really none of these should be nullable. All basins should really have these. I might leave that because some of these are, but really these 4 fields, I think the it should all have. Okay, so obviously this isn't our finished schema. One of the things you can do with Terraform, though, is we can just run a plan, see if it throws any errors. Obviously, I just want to kind of double check how this is looking. Oh, it's saying the infrastructure contains no changes. That's odd. Oh, I didn't fill this shit out. So, even though this is the schema we're using right now, we haven't really added anything to the main file. So, what we're going to do is actually do that. So, basically, like this suggests, we're going to create a resource, which is the table. And then it's going to be a data set. So the data set's actually going to be the data set that will hold everything. And then, yeah. Okay, so we're gonna create this. We're gonna copy this. And then go from there. So I'll start just by copying this here. So we'll change this, obviously. So we're gonna call this data set, what were we calling the final version of this? I think, gotta remember what I was calling this. Oh yeah, overleaf. Okay, I'm gonna call it like, I think we're gonna call it like, shit. Yeah, I'll just call it that. Okay, so HydroNet. Shit, I just fucked that thing up, I think. Yeah, we'll just call it that. And then below that, we'll put the actual table. So schema is going to be a path, though. I don't know if that's actually the way to do it. I'm hoping that's actually used the way it's done. That would be a help. Let's try this. Oh yeah, these aren't imported yet, so that's why. Table ID. We're going to call this gauge meta. Time partitioning. Type. Okay, we need to look at time partitioning. Okay. Actually, for the meta, I don't think we need time partitioning. That will be useful when we create the actual core code. So again, we create this main file. Then the main file has to be imported into kind of our main crap. So we can do that. I don't. Okay, the main modulo. So then we can do tables. Basically same deal as before. We go like that, I think. Oh yeah. Shit. I'll go back there. So what was it complaining about? Argument definition must end with a new line. So it has to end like that. No, I guess it doesn't like this. Yeah, see, I thought this was a problem too. Oh shit, I think I fucked up. No, so that first one shouldn't be that, yeah. Yeah, the first part's always this kind of module. So this should be this, and then we call it HydroNet. And then, yeah, that looks right now. Okay, now we can try Terraform plan. Oh, yeah. Default. .hydronet. Yeah, this is pretty self-explanatory. Invalid path. No file exists at schema meta.json. I wonder if we did an absolute path. lscd. Yeah, I mean, I don't know. This will work. I'm not sure exactly where it's reading this from. Okay. Project. So it's saying BigQuery dataset. Well, isn't project just going to be the default one? Yeah, I mean, it's always going to be this project. I mean, really, this should probably be passed as a variable. but I don't know. I'll look that up quickly. Why isn't this searching? Wait, no, I don't want bookmarks. Projects. Project required field is not set. Oh, it's in the table. I mean, I don't see why it's requiring a project here. Oh, it's saying both of these need a project. See, I mean, like, now the project here, particularly if we were doing, this, we would not want to hard code this. We instead want to do something like, I think, like, yeah. Oh, we'd want to use this thing. Yeah, we want to do, I think provider could be, this could also have a, or maybe, at the very least, you could do something probably like, yeah, so we could do that. Well, no, this would be this, right? Oh, that was another bad suggestion. Okay, so that would be good. I forget if... I don't think this is given a variable name. Okay, maybe I can't do that. But that's how that works this way. Yeah, I don't know. Maybe you can't do that as a provider. In any case, we'd run the plan. We see it's going to create this kind of table. The truth is, right now we're not going to create that. Though, I mean, we could run this plan, I think, and then we could probably remove it or change it, and it should override it. but I'm not going to bother doing that right now, I think. But now at least we have this kind of set up. So as we add fields, we can kind of keep editing this schema to get it to the point of where we want. But in the meantime, we have to, I think, look at the actual metadata. So, and add the metadata. So the other things we're going to add to the metadata were the scan stations. And again, the scan stations are to get the soil moisture. So one of the things that's going to then go into the metadata too is basically the closest scans station. So the closest station with soil moisture data, and then that will be another source we query when creating this large table. So again, if we remember a couple of weeks ago, we talked about how we could generate scan reports, but I don't know the easy way to look up all the scan stations. Because I think it was kind of a pain. So scan, remember, was soil climate analysis. And anyways, what we need to do in the metadata is kind of similarly to how we calculated the closest ESA station to calculate the closest scan station. So basically, though actually there aren't that many scan stations, there's only 200 of them. So a lot fewer scan stations than ASOS stations. But at the same time, it would be good to get a master list of all of these and their latitude and longitude. So that's what I'm going to look at how to do right now. Because once we have that list, then we can, of course, calculate the closest and write some, or even reuse some of our other code. But we need to get that kind of list of basically the station IDs and their longitude and latitudes. So, I think interactive map. So this was a report generator. Yeah, these are the things we want and that we'll add, obviously. But we need to know what about the soil moisture sites, like, and where they are. And hopefully get a CSV of them, not just a map. Scan station inventory. So these are the 212 stations. I mean, it looks like they're pretty sparse in a lot of places. Particularly the Midwest. Like, I don't know if there's many at all in several of these states. Oh, there's not many in New England either. Like in Maine, I don't think there's a single scan site, which is kind of annoying. So, yeah, I mean, something to also do, I feel like, as you're exploring data sets is keep updating the documentation too. Because otherwise, I feel like you end up repeating a lot of this stuff. And you obviously don't want to repeat a lot of this stuff. I think I listed soil moisture. Oh, I just said that was a bonus. Metadata scheme. So, yeah, that's not what I really care for right now. I want to create a thing on the soil scan data. So, in any case, yeah, we want to get a list of all the scan stations. So, I don't know if there's an easy way to do that, though. Oh, wait. But if we, on the other hand, though, if we take this, okay, we have selected stations. Okay, yeah, actually, this is exactly what we need. I'm hoping. Ow. Okay, I don't care about that. What I care about is the station. And these all seem to be scan, and then their latitude and longitude. So even this, though this is for obviously some random dates, it basically lists all the stations and their latitude and longitude. So, I'm actually gonna upload this file and probably label it as something else. I'm gonna create a file called metadata building files. And this will be files that we use over time, just so that there's a record of the original files. And I'm gonna actually download that scan sites, and as a CSV, we'll upload that. So we now have the list of the sites. Again, I think we can reuse some of the code that had like the haver sign and all that shit. I don't think it was in this file though. It's very similar to what we did with the adding the SNOTEL data, except now it's soil moisture data, so I'm thinking we can actually reuse these functions to do it. So, what we can do with these is we can, so add SNOTEL meta, base URL. Okay, so I think this is a similar idea, except here we're gonna actually, instead of querying, we're gonna open this CSV file, etc., etc. And that should hopefully work. So I'm gonna actually create a new thing. Again. I'm gonna call it add moist. But the idea of this is, now for every place, we'll calculate, like, what are the closest stations. So, scan data. Likewise, going back to the schema, I think we'll have probably then several fields in the table related to the closest scan site. We can quickly look over some of this data too, see how much sense it makes. So yeah, those seem to make sense, at least to me. Okay, that's uploaded. So yeah, for the soil moisture, I'm also gonna look into, I guess. I mean, obviously it's somewhat problematic. There are only 200 stations across, a country of 50 states. Because that means, of course, there are some states that have a lot of them. Then there are states like Maine that don't appear to have a scan station at all, with the kind of daily soil moisturizer data we want. So what we can do is, so with this kind of report, we can, okay, so these are like the fields that we'll see in the report. As for the station, so yeah, we can just do this add moisture notebook. I think this will either way be pretty similar code. I mean, the hover sign is really something that should be committed to the main repository and just imported again and again since it's used so much. So I'm going to create anyways this function. Obviously, the intention is not to do it for Snowtel, but for other sources. So we'll put in a CSV path in order to open that kind of long file there, as opposed to querying a URL. We'll switch this to scan. So this is going to be similar. Only difference is this will have to read probably as a data frame. So So yeah, we can get rid of all this base URL. I'll do that in a second. But yeah, so this is going to become essentially another pillar of this. We'll have scan also from the USGS. And they'll provide us using that URL I showed earlier. Potential help getting it fixed. Oh shit. Okay, so this was the plan. I mean, yeah, let's, I guess, go actually edit some of the schema. But first I am gonna pause for a few minutes and then come back, so. Okay, so we're back. Yeah, that was just a quick break as I had to do something. But, so now, we will need #sign again. And then so yeah, again, okay, so yeah, here we'll probably have to kind of brute force these. So we could open the CSV path. I don't know why I don't just delete it, actually. I do have the whole other notebook. Okay, so yeah, we can just do that. And to start with, we need to import pandas. Yeah. Okay, so yeah, we're filling that in. I might also begin to update the diagram. Though, I mean, really, yeah, I mean, it's a different network in USGS, so it's not entirely clear how you'd update it. But, what we'll do is so yeah, but it's definitely a different API call, so it does make sense to show it again. Well, I mean, and technically the Snowtail data is also from USGS, but it never surfaces. So we can do scan data. And then, yeah, I mean, then it would be somewhere. But, yeah, I don't want to have that. In any case, so that will be a different source we get information from, and then, yeah, and then that will be kind of joined together into this master data frame for each gauge basin. So going back to the schema. Oh, where did I put this? Oh yeah, that was uploaded, so I don't need to worry about that. So this opens that. Now we can continue to look at the schema. Okay, so I'm gonna change these. And what we're going to see is I am going to have one for the closest scan site. And what we're going to do is we're going to do type. Is that what I want? Yeah, so this will then probably be a string. I need to look at how these sites are named though. Because I'm not actually sure. So, okay, so these are the names. So it looks like those will be kind of a string according to that. So, yeah. So, oh, where did I do that? Oh, shit. Yeah, I didn't want to do that there. So instead, we'll just copy and paste that. So, closest scan site, this should be a string. Yeah, I didn't fix that well enough. And then okay, that looks about right. So yeah. And then, yeah, we're going to have a couple more fields over the next couple days that get added to here. This is why I haven't run the final code, of course, to create the temple, to create the table. But I definitely plan on doing that once I get those the final things ironed out. What extension is that? And then another, so closest scan site and like that, then we'll do closest scan distance. And then, yeah, I don't know if we'll include all the others in JSON. Maybe, actually. Then the other thing as this data, gets more sophisticated. Yeah, we need to keep like good track of the different types and just make sure it's accurate. And then once this thing is actually loaded into BigQuery, I think we're going to need to make some examples of how to query it and then add it to the docs. Because otherwise, again, it's like not enough. A lot of people are actually learning to use it, and unless you have like good documentation on how to actually query the data. So that's going to be kind of the task for next week. Okay, until then, yeah, I'll see yeah, just see everyone, I guess. So, and then yeah, hopefully next time we'll actually get to run the plan and create the table, and then but then even after we do that, then we'll have code to write all the metadata to the table, which is also going to be somewhat difficult, but anyhow, that kind of looks like what the schedule will be for the next upcoming weeks, is getting the idea of the tables figured out. So